I wasn't planning to do a big episode on die studies. I was thinking of doing a general channel retrospective, but it seemed a little bit self-indulgent after my last episode on the subaltern. So I got a little bit distracted. I ended up looking at a bunch of stuff about meta-die analysis, and I thought I would like to talk about that, particularly the part of meta-die analysis that's concerned with reconstructing the original production of coins and the practical issues that presents, not the theoretical ones, the actual practical difficulties that get in the way of reconstructing economic data from die studies. Yes, this is going to be a long episode. For a period in the 1960s and 70s, quantification was the great hope economic historians had for die studies. But with the arrival of monetary history into numismatic departments, the die study as a taxonomic tool appeared parochial and self-indulgent. Numismatists came to sympathise with historians, who generally find anything below the broadest classification of types to be hair-splitting. However, before that happened, it seemed possible that systematic application of die studies might allow numismatists to reconstruct data series quite unlike anything else that survives for the pre-modern world. That idea came under sustained theoretical attack in the 1990s, in a fractious debate initiated by Ted Buttrey. I don't want to look at the theoretical problems today. While there is a lot of very naive uses of meta-die analysis, the failure to realise its potential value for economic history has much more to do with practical difficulties. And to talk about practical problems, I need an example, which today is the English medieval penny. In the late 10th century, the English monetary system was reformed, and this is the type that kicks it all off. Edgar's reformed type, a type which was also issued by his successor and is the first type of Athelred. For the next 200 years or so, a single denomination, a silver penny of 1 to 1.5 grams with a low relief design, made regional mints, but unusually for such a distributed system by dies that were engraved centrally, primarily at London. The design of the coin would be changed at frequent but probably not regular intervals, resulting in a consistent need for recoinage and probably a significant profit to both moneyers and the crown. This is a very unusual system. I have seen suggestions the Sasanian Empire in Iran also centrally made dies and distributed them, though I've never actually seen any evidence for that. But by and large, if a state had regional production, regionally manufactured dies. And if it centrally manufactured dies, it was because it made its coinage centrally. As an aside, and there are going to be a lot of asides in today's episode, the English system of centralised die production is not an example of die transfer. It's completely logical if you've heard the term die transfer to think that making the die in London and then moving it to another mint is an example of that. But it's not. Die transfer, which absolutely definitely happened with English pennies, is where a die is used in one location, then transported to another location to be used there. The reason that it's important, and often controversial in die studies, is that it violates the principle of die identity, the idea that two coins, which are connected by a common die, were made close together in space and time, and by extension, therefore, that coins which are connected by being part of the same linkage also have a proximity in their manufacture. That's a topic for another episode. Anyway, why medieval pennies for this episode? Well, for much the same reason the last few episodes were about Republic and Roman coinages. There are a bunch of peculiarities about this coinage and its scholarship which make it a particularly good example. And one of these is the result of two articles in 1965. Written by Michael Metcalf and Peter Sawyer. These are two of the most remarkable examples of hope and optimism triumphing over evidence that I have ever read. What both Metcalf and Sawyer wanted to do was estimate the size of England's circulating coinage from the 10th to the 13th century. England has unusually early administrative records, but like almost everywhere, there is a limit to how far back they go, and that limit is the 13th century. The hope was that numismatics could fill the gap, extending the record back several more centuries. Metcalf and Sawyer thought it could, and as luminaries in their field, they quickly committed almost everybody else to a decades-long research project to do just that. I said these works are examples of hope and optimism over evidence. Let me explain. Both scholars understood what you needed to do, in principle, in order to generate the data they wanted. And it could be divided into 4 steps. First, count the coins which survive and identify their dies, which is the basic task of creating a die corpus. Secondly, you take that data and estimate from it the number of dies that had existed. That's a statistical problem. Third, based on that estimate, you need only multiply the number of dies by the average productivity of those dies. And the fourth step was to use those levels of production to infer the thing economic historians actually wanted to know, which is usually the amount of circulating coinage. To recap, make a corpus, statistically estimate from it, multiply by productivity, and make an economic inference. Simple. Except in 1965, no one had a die corpus. There was literally no data, and no one had any idea how to estimate the original number of dies, or how many coins a die made. We still have no idea how to calculate that. And it should be no surprise that not a single economist had any idea what to do with this data, because they'd never actually seen data like this. Like I said, hope and optimism. Metcalf and Sawyer had no data and no tools, but they believed passionately that if they generated the former, the latter would appear. I said I wanted to focus on practical rather than theoretical problems, but I do need to cover this. We have no idea how many coins a die makes, and we don't know how to work it out. And the most common way to work around that theoretical problem is to assume that the dies make a very similar number of coins, even though we don't actually know what that is. And that seems justified when there are common technical and administrative procedures for a particular coinage. And for a period of about 300 years, from the late 10th to the early 13th century, English coins were made under strict administrative control with centrally produced dies in a single denomination, the silver penny of 1 to 1.5 grams. So, just for this episode, let's dodge the theoretical problem and pretend that we think that they make about the same number of coins. There are actually some reasons to be uncertain about that, but we're all just going to pretend they don't exist in order to be able to proceed on the assumption that if we complete the first 2 steps in the process, we will have a measure of relative production. I've introduced the project Medieval Numismatics embarked on over 50 years ago, and if you want to see how that is viewed by the field itself, I suggest 2 articles. It feels a little odd to recommend reading in an episode like this. I'm trying to envisage any situation you would set a reading for a group of students on this topic, and if you were the kind of person who did that, why you would need my help in choosing that reading. But I think these 2 articles are particularly good because they show the way the field itself thinks about the project. At least the part of the field that hasn't become totally disillusioned with the whole thing. And that is kind of useful because I'm approaching this from outside the field, from the point of view of die studies. And if you were genuinely interested in the problem, you would want a broader perspective on it that I am going to offer you here. For the benefit of anyone who is still listening, here is the plan for the rest of the episode. We're going to pretend that we've successfully sidestepped the productivity problem, and that economic historians would have the faintest clue what to do with this data if we got it to them. And so, we're going to go through only the first 2 steps, using all of the data since Metcalf and Sawyer committed the field to this problem over half a century ago. Die studies of these coins come in 2 types, vertical and horizontal. The difference is to do with how the coinage is organised. Though the dies were made centrally, the reverse dies were marked with the name of the moneyer and the town in which the moneyer was supposed to operate. The inscription begins after a small cross. Then, in this case, the name Swartink, that's the moneyer, then on, that always interrupts the moneyer's name and the location, and finally an abbreviation of the town name, in this case Lynn for Lincoln. The general practice is to refer to that town as a mint, and sometimes that's true, but really the town is just an administrative location. There might be multiple physical workshops independently running in the same town. And of course, there might be just one. The existing die studies suggest that over time, it becomes more common for all work to coalesce into a single location because we see more sharing of dies between moneyers in the same time. Oh, a quick note on moneyers. I suppose it's possible that occasionally someone named on a coin actually got their hands dirty, but these are mostly relatively wealthy individuals who run the whole money changing and minting operations and presumably have a staff working under them who are actually making things. Vertical studies follow these mint towns over time, and the first vertical study to be published was Lincoln by Mossop in 1970. Mossop looked at over 5,000 coins from the reign of Edgar to that of Henry III, which is nearly 300 years. It's broader than we're actually planning to look at today. While Mossop was finalising his manuscript in 1968, Yvonne Harvey was approached to produce a very similar vertical study for the Mint of Winchester. Winchester was an important centre, and it was one of the suppliers of dies before London monopolised that role. However, the publication of Winchester did not arrive until 2012, 44 years after it was initiated. And that's an important practical point. Die studies take a lot of time. Winchester is accompanied by a series of articles by various specialists. If you're interested in this period, it's the publication I would start with, assuming that your interest in the period is die studies. In one of these, Stuart Lyon compiles the results for Winchester and Lincoln into a single table covering the types from the reform in the 970s to the reign of Henry II. Approximately 50 types over about 200 years. Lyon adds to this data a third major mint, York, based on an unpublished study by William Lean. So straight away we have three major vertical studies and data from more than 15,000 coins. And Lyon's specialist knowledge is really useful because the type descriptions aren't 100% consistent over the last 50 years, so it saves me a bunch of time trying to deal with that myself. In 1999, Robin Eaglin published a study of the Mint of Huntingdon in the British Numismatic Journal. We can extract data from Eaglin that we do run into some problems. There are some terminology differences with Lyon's arrangement. For example, Eaglin gives British Museum catalogue numbers here rather than referencing the names of the type, which is how Lyon does it. That's not too bad, but Eaglin treats the expanding cross as a single type, where Lyon divides it into a light and a heavy group. You're probably thinking that's not a big issue. Surely we can just treat Huntingdon as having a single expanding cross and the other mints as having two types. How much difference is that really going to make? But the devil is in the details, and I need to let you in on a secret about this formula, ND over N minus D, which nowadays is the standard we use for die studies. And to do that, I need a little bit of data. So let's put some numbers up on the screen. These are for the coinage of Athelred, and they're from Winchester. They are 7 different types, and they total 1,977 coins. Each of the different types, there are this number of coins and this number of obverses, and I've recorded the total at the bottom. Apply the formula to each of the individual types. We generate an estimate of the number of dies that were used for that type, and we add those up to get 733 dies for the whole of the reign at Winchester. But now, instead, we apply the formula to the total for the reign, and we get an answer of just 621 dies. Yes, 112 dies vanish because of the order in which we add something up. Why does this happen? Well, it's the relationship between N over D, the average number of coins per die, and the formula we use for the estimate. Take the beatific hand type. With an N over D of just 1.5, the formula says we're only going to have a third of the original dies. There are a lot of missing dies for this type. But once you get up to an N over D of 4, the formula reckons you'll have 75% of all the dies that were made. In Ethelred's reign, we have these early groups with very low N over D, but quite a lot of dies known, and then later groups, like the Long Cross, with a very high N over D, but very few dies. When we combine them together, the result is a reasonable N over D that cloaks the absences in our poorly represented groups. Obviously, if all the groups were known from identical samples, this wouldn't matter, but that will never be the case. And as a general rule, the more you clump coins together, the lower the estimates of dies will be. The more you split them apart, the higher the estimates will be. Not just in this example, but for almost any group of coins and almost regardless of how you split or clump them. Generally, we are looking for relatively discrete groups with minimal die linkage and of rough equivalence in size. Reigns of kings are not particularly good because they vary a lot. Working our way all the way down to individual linkages is not great because it leaves us lots of data we can't use. So we gravitate in on types. Ethelred has 7 of them over 37 years. Harold has 1 of them over 1 year. It's a 37-to-1 relationship in terms of their reigns, but it's only about a 5-to-1 relationship in terms of their types. And that is why we're doing it with this particular frame, and why it's always best, insofar as it's possible, to compare like with like, and why Eaglin's failure to split the expanding cross versus Lyon's decision to do so causes us problems. Okay, back to the data. In 2006, Eaglin followed up his Huntingdon study with the mint of Bury St Edmunds. Bury St Edmunds is an ecclesiastical mint, privilege extended to an abbey to allow it to make coins, and it opens in the reign of Edward, part way through the period we're discussing in this episode. Fortunately, Eaglin summarises the data we need in a table at the end, and the dataset is relatively small, so it's not difficult to add this to our existing data. Finally, between 2010 and 2018, we have the publication of Ipswich by Sadler. I don't want to moan about Sadler's study, but it's like a student explained a die study to a Martian, and the result, while not in any sense technically incorrect, is almost dauntingly unusable. Sections of it read like unorganised notes, and though Sadler does record dies after each money year, except where he doesn't, there is a lot of tedious flicking through pages to scrape out numbers. There's also a moment when the whole thing is interrupted for a bunch of drawings which appear to be of dies, but known examples aren't listed, so they're completely useless. And when the catalogue gets to Stephen, it announces that due to the poor state of the coins, it won't include die identifications. Except it then does include die identifications, but skips them in 2 small sections. That's just too irritating to let stand, so I felt the need to pull all the data out, look at it myself, and do my own calculation of the number of dies. So I thought it'd be interesting to talk about actually doing the die study of the Stephen material. Practically, the first step is to separate out all of the low quality images and worn coins. You should start with the better images and work to the worse ones. So we separate all the bad images off into a different folder, and we start with this coin. We assign it the die numbers 1 and 1, and now we compare it against the next coin. Put a new image in and scale the 2 to roughly the right size. This feature would rule out the same die, but maybe we have the rotation wrong, so we rotate it and then check again. But there are some links. The midline here meets the same letters, and if you draw a line through the cross, then it meets the inscription on in the same place. There is some double striking on the coin on the left, which makes this hard to see, and obviously they don't quite cover the same area because they're poorly struck. The next step, having identified these are from the same dies, is I load them into a graphics program and I make a composite image of these 2 images. I could do with tidying this one up a bit. The composite is a final check on the die identity because it should create a seamless connection between the images. The little kink in the dotted circle is not a break between the images, it's a feature that's actually visible on one of the coins. Composites were pioneered as a technique by Jean-Philippe Fontenelle and John Talbot, working independently on the coinage of Herod, which is grotty copper, poorly struck, much like this, and on the coinage of the Iceni, which is frequently off flan. And that is why you start with good images and work to bad, because the composites help to bridge the gaps between coins of low quality. None of this is difficult, there's no real theoretical issues at stake here, but practically speaking, it's just very time consuming. Anyway, back to the data. At this point we have 6 mints, which the astute listener, and I assume all of my listeners are astute, will realise is not enough mints. In fact, more than 70 mints operated in this period. And worse, one of those London is significantly larger than any of the mints so far examined. But how much larger, and how to move from just 10% of the mints to a picture of all of them? Having gathered the vertical studies, following a mint over time, it's necessary to turn to the horizontal studies. On a regular basis, the types of the coinage were changed. For example, in the reign of Canute, the types in which pointed helmets are depicted are succeeded by types with a cross. Horizontal studies take one of those types and track it across all of the mints, and the period is bracketed by sets of data. Johnson produced a study of the reform coinage, which was published in 1987. I'm not sure if I mentioned, but after Edgar's reform, the same type is issued under his successor Edward, and it's the first type of Athelred. That is a major inconsistency in our data table because Lyon treats those as a single group, but by the standards generally used, they ought to be divided into three. But unfortunately, Lyon is referencing a set of data that isn't published from York, so it's very hard to recount that and break it up. Instead, what we have to do is amalgamate Johnson's data, a less than ideal solution. At the other end, we have an article by Allen in 2006, which includes a study of Stephen type 7. Again, Lyon amalgamates type 7 with all of the other Stephen types, though judging by the numbers in the two studies, type 7 seems to dominate. It also includes revised numbers for the following cross and crosslet or Tealby types of Henry II, which had been first examined by Metcalf in 1977. These are not ideal. The monetary system is changing again at the end of the period we're looking at, which ultimately results in the subsequent short cross coinage. And if that change is already underway in the reign of Henry or potentially Stephen, then our assumption of common technical and administrative procedure is void, which, and it is always useful to remind ourselves of this, is absolutely vital if we're going to use dies as a measure of relative mint output. Ideally, we would want a horizontal study of the last type before Stephen, but we can't always have what we want. We also need some data in between, and there are essentially two data points available to us, both from studies by Hugh Pagan. Pagan compiled a corpus of the PAXC types of Harold II, which includes counts of coins and dies, though it's not a full die study. Pagan did produce a full die study of the PAXC type of Edward the Confessor. And though this is a very thorough study, there is no tabulation of the number of obverses, so I had to count this out of the catalogue. Essentially, I took a photocopy with me on a long trip and I just went through the catalogue counting out the dies one at a time. Then what I did was I compared the results that I got with the results that Pagan got, where Pagan chose to actually report the count. And anywhere they disagreed, I went back and checked it again. That is called a verification step, and it's really useful. On balance, it turned out I was slightly less reliable than Pagan, but we both made errors. Since I was counting, I also had to resolve a bunch of counting problems. A common one of these is to do with mules. And mules are a common feature of England's constantly changing coin types, with dies from an older type being combined with dies of the new type. I'm not clear on why this happened, whether it's a chronological thing that happens at the start of the reign or a result of errors or shortages of dies or some mixture of them, and I'm not sure if this is a question specialists in this field have an answer to. By all means, if you're a specialist in this field and you have an answer to it, feel free to put that in the comments. Pagan ignores mules in counts, but lists all of them. This diagram shows all of the examples. The dies marked in green are listed in the corpus because they are known from die combinations that belong properly to the PAXC type. The dies marked in yellow are noted but not listed in the corpus because they are only known paired with a die from another type. It's not clear why there are so many more of these at Lincoln than any other mint. It might simply be down to the fact that Pagan had access to a vertical study of Lincoln and didn't have access to vertical studies of the other mints. But that's precisely the kind of feature that undermines our confidence in common technical and administrative procedures. There is no standardised way in how to handle this or other oddities. Johnson, for example, counts fractions. Allen assigns things to the first entries in a list, which means with mints it's literally done alphabetically. Eglin assigns the numbers in different places, which leads to oddities like this one, where the dies 4 outnumber the coins 2. How should we count them? There isn't a really good answer, and it's not just mules. How do you deal with coins where only one side can be identified? What about obverse dies that are shared between moneyers or between mints? And so on. Yes, all of these are theoretical issues, and I said this was an episode about practical problems, but the theoretical issues here create a practical problem. It doesn't really matter how you choose to count. The important point is that everybody needs to count it the same way, and they don't, which means you would need to go back to the studies and recount all of them. You've kind of got to do that anyway, because if you're going to use this for anything other than an illustrative purpose, if you're really seriously going to use the data, you would have to perform a verification step, as I did on the Edwards study. But this episode took me weeks to put together, so there was no way I was going back and doing all of that. I have no idea how much longer that would take me. But as it stands, that is a practical barrier in your way to using this data. Technically, there are a few other horizontal studies. The PAXC type, which is sometimes assigned to William I and sometimes to William II, was looked at by Metcalf and later by Allen, but I came to the conclusion the data looked badly compromised and was best unused, which is a pity because it would be a really good data point. This is a part of the spreadsheet I've been dumping data into. The 6 vertical studies are on the left. The data from the 5 horizontal studies is marked in grey. Only some of the mints are visible on this section. In total here, I have 79 columns of mints and 49 rows of types, though of course both would vary depending on your approach and likely increase if you added more studies. It's been a long slog to get here, and this is a huge amount of data, 17 to 20,000 coins, more than 12,000 dies identified. I don't think it should come as any surprise that this took more than 50 years for the field to assemble. And I don't think Metcalf and Sawyer really thought about that in 1965. I don't think it occurred to them that it would take large chunks of the careers of 8 different scholars, all of the people who supported and encouraged them, just to get data on less than 10% of the types and mints. Die studies are laborious, and it's not just because of the die identification, but slogging through collections, publications and auction catalogues to get the data. Okay, so now we have data. Collectively probably the largest data set of its type ever assembled. It's really tempting here to try and solve the resulting grid of data like it is some sort of complex Sudoku, and I'm exactly the sort of historian who would be tempted because I very much approach history as a series of puzzles. I suspect a frame of mind I share in common with Metcalf and Allen, which probably explains why they have returned to this repeatedly. But I think it's a mistake. I'm still going to explain how I would do it, but I think it's important to understand that doing this seriously, rather than as an illustration of the practical problems as I'm doing it, would be a methodological error. First, I would rearrange the grid in a more useful order. At the moment we have the 6 vertical studies on the left and the other mints in alphabetical order following them. I would arrange all of the mints by their approximate size. We can do this very roughly with the dies. For example, Canterbury over the 4 horizontal studies has 31 obverses and 29 reverses from 46 coins. That gives us an estimate originally of 95 and 78 dies. But Bristol has just 5 of each known from 12 coins, which indicates about 9 and 9. So we can assume that Canterbury was quite a bit larger than Bristol. Unfortunately, we can't actually use the reconstructed numbers, and I'm going to come back to that in a bit. So I had to settle for the moment on just sorting them by the number of extant dies. Now, let's look at this section of the reorganised chart to see what our next step would be. The mints are arranged left to right from largest to smallest, and that means in principle something could be inferred about the minting at Norwich. The simplest way would be, since there are 2 mints between Winchester and Ipswich, is to apply a simple weighted average. That could then be adjusted by the trend indicated by the horizontal studies, which bracket it chronologically, which in this case looks like a relatively flat trend. To do that, first we calculate the original number of obverse dies from the data that's available. Then we take a weighted average so that the value falls roughly 2/3 of the way between Winchester and Ipswich. Obviously, this only works well when you're interpolating a modest amount, 1 or 2 mints between data sets, and only where there is solid data. The missing value for the Sovereign Eagle is not a transcription error. The problem is that you cannot extrapolate an original value for Ipswich because there are only 2 coins and they are known from 2 obverse and 2 reverse dies, and you need at least some die duplicates before the formulas even work. The question of how you calculate the original number of dies was something people did not know how to do in the 1960s and 70s. Yes, medieval numismatics embarked on a massive multi-generational quantification project in the 1960s without the basic tools necessary to interpret its data, just hoping somebody would solve the problem before they got to the end. That really happened. And someone did solve the problem, though not someone working on English coins. In the intervening 50 years, we have reached a solid interim solution. ND over N minus D, and the standard references are SD 2011 and SD 2006. SD 2006 also includes a formula for a confidence interval intended to measure the sampling error. I've not in the past been a huge fan of using confidence intervals. I always felt formalising error led to a false sense of confidence, that the answer must lie within those bounds, and I've seen articles in which numismatists make that mistake. But I've also come to realise that very few numismatists are numerate enough to depend on a critical and intuitive understanding of their samples in the way they would for more conventional sources. Here I've plotted 3 lines onto a chart comparing the number of dies known to the N over D values for those dies. The lines represent different relative error margins from 40% to 10%. This indicates what I would call a zone of no confidence in the bottom left, a region representing samples too poor to be useful. Essentially, anything with an N over D lower than 2, any modest number of dies whose N over D is not very high. First of all, I calculated the index number, which is essentially the average of the N over Ds for the obverse and the reverse. The advantage of an index number over an N over D value for the obverse is that it's a measure of the completeness of your sample, which is comparable between coinages with different ratios of obverses and reverses. I added a sheet to my spreadsheet which calculated this and the N over D values for the obverse and reverse, and then applied a simple conditional formatting to tag everything less than 2 in red. And as you can see, there's a lot of data falling into that zone of uncertainty. If I then limit the calculation of original number of dies, just those data points with an index number over 2, we are reduced to this. Yeah, there's not a lot to work with here. Pans out that it is possible to reconstruct estimates that are not wildly unreliable for about 5% of the total coinage. Nowhere near enough to make the sort of interpolation I talked about earlier even slightly plausible. And again, getting here took over 50 years. I mentioned earlier that the sorting of mints into a rough order was not terribly reliable and I wasn't able to use an estimate of the original production. A little aside, the reason I wasn't able to do that for some of the mints is due to the data on the coins, which even when amalgamated from 4 different horizontal studies, which generally suppresses uncertainties, still fell into that zone of uncertainty. Well, it turns out there's a pattern to that, and it's an interesting one because the field in general broadly assumes that mints with very few dies have very few dies because they are small mints. But, well, I tabulated it and it looks like this. I've arranged the mints in descending order of surviving dies, left to right, top to bottom, from the horizontal studies, and colour-coded the index number. Green means 2 or more, yellow is 1.5 or more, orange for less than 1.5, and red for those with an index number of exactly 1. That is, no die duplicates. The concentration of red numbers and the general trend for the samples to get worse, the number of surviving dies gets smaller, is important. It undermines that field-wide assumption that a small number of dies surviving indicates a small, unproductive mint town. It's absolutely true that some mint towns probably were small. Lidford, Romney, the data for those indicates that they were small. But it's also the case that a lot of mint towns that appear to be small and are assumed to be small were probably actually significantly larger, and the problem is just a lack of data. Let's go back to where this all started. Metcalf and Sawyer committed their field to recovering economic data from die studies in 1965, and though this use of meta-die analysis has become widespread, no field embraced it as enthusiastically as this one. When they did so, they had no data, no idea how to use it. We still don't know how to use it because we still don't know how to solve the productivity problem, and even when we can bypass the productivity problem, which we've pretended we can do so in this episode, we still have just 5% of the data and a huge bunch of theoretical headaches from counting procedures to systemic distortions. And a massive pile of practical problems. The task is incredibly labour intensive, and while digital photography and computers help, they are a long way from solving any of those problems. This episode is not a counsel of despair, and you should be wary of reading it as such. I am not suggesting for a moment that you cannot use die study data to quantify English coinage. In fact, what I was able to do here should demonstrate that if you did in fact have enough data, you probably could. Nor am I suggesting that the effort that went into the die studies is wasted. Neither of those things would be true. Die studies are incredibly valuable, and there's no question the detail in which the English silver pennies are understood on the cusp of records surviving is in large part a function of the close attention that has been paid to die identities by numismatists working on the period. And as I'll probably cover in another episode at some point, at least one of the studies of English coinage has a direct bearing on theoretical problems in die studies generally. Die studies are incredibly useful, and they can serve as a very effective starting point around which to hang an in-depth analysis of a coinage. But what I think this does illustrate is the genuine practical problems faced in trying to use die studies as a tool for quantification, because what you need as raw data is not itself simply contained within a primary source. It is an inference that needs to be made from the primary sources, painstakingly, carefully, by forensic analysis. You will be disappointed approaching a coinage with this tool and the same purpose Metcalf and Sawyer intended because of the practical difficulties it presents. And I think that's an important point to make. There's still a tendency in the literature today on classical and Hellenistic coinages, I think encouraged by the American Numismatic Society, to present die studies as primarily existing to serve the purpose of quantification, when in fact they work better as microhistory of a particular historical institution, the mint. In classical and Hellenistic coinages, where nothing but the coin survives, that misapplication often leads into methodological sloppiness. But in English coinage, where there are alternative sources of data, I think over the last half century it has frequently led to disillusionment with the process. I think that disillusionment is palpable in the literature, a sense that die studies have in some sense failed, despite the huge gains that have been made through them, because they failed to live up to that hope that existed for them in 1965. Okay, I can't resist one final thought, because in many ways I'm very sympathetic to the scholars who tried to do this. One of the things that the current data does give you a clue for is where to look next if you want to continue the project, to ensure that the next 50 years of data collection is as good as it can be. You see, horizontal studies give you a clue as to where you will get rewarding vertical studies, and vertical studies give you a clue as to where you will find rewarding horizontal studies. Let us start with the vertical studies. Present, these are located in the northeast and with major mints. We need vertical studies to be much more representative in order to draw meaningful conclusions and to make any attempt at interpolations. There are, for example, no studies in the West, and unfortunately none of the data we have indicates particularly good index numbers for any of the mints in the West. I suspect that Bristol is probably the best bet. So that would be something you'd want to include in the future. To cover other parts of the country, I would suggest Warwick, Steyning, Lidford and Sandwich, which also gives you a much broader range of the sizes of medium and smaller mints. And all of those mint towns have good index numbers, so you'd be likely to get good results from them. In terms of horizontal studies, Ethelred's Long Cross is the first I would suggest. Every vertical study shows a remarkable sample for the Long Cross, and it's an obvious target as it falls between two existing horizontal studies. The PAXC coinage of William I and II has already been mentioned. I think the existing study is so badly compromised that it's not actually useful, so I think doing that again properly would be a genuinely useful addition to the data. To these I would add a study of one of Canute's types, the pointed helm or the short cross, Edward's expanding cross, and the first type of Stephen. A type of Henry I would be ideal, but the samples all look relatively poor, so it's probably best to settle for the earliest type of Stephen. Would this be enough data to infer from? I doubt it. You might expect it to get you to 10%, at most 15% of the data, and of course you would still need to do the verification steps and resolve all of the counting issues, and I'm pretty doubtful, even if it's quite robust, that would be enough. 50 years from now, with that additional data, you might be able to work out how many more such studies are needed, and if you have an abundant supply of optimism, it's even possible that some of the theoretical problems might have been solved by then.